30 picks up where lesson 28 left off. In lesson 25 of geometry, we talked about side-side-side congruency postulate between three triangles. In lesson 28, we talked about side angle side, so we learned about included angles and included sides. That's a side that exists between two angles, or an angle that exists at the vertex of two sides. Today we're going to talk about triangle congruence. We're going to add two more to the list. We had been going kind of one at a time here. We're going to talk about angle side angle and angle angle side, okay? Which I believe, with the exception of getting into like angle 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 side or angle side angle angle, basically anytime where we have three angles in one side, right? That's the only one that's really left, okay? Let's see. So there are many ways to prove triangle congruence. Basically, what are we talking about when we talk about triangle congruence? What are we trying to prove? That they're congruent. But what does the term congruent mean? Not similar. Same, right? Similar is a totally different thing, and it's a good, I'm glad that you actually bring it up. Similar means same shape, different size. Congruence means what? Same shape and size, right? All right. So in lesson 25, we learned about three consecutive sides between two triangles to prove triangle congruence. We called that the side-side-side congruency postulate. Lesson 28, we learned that congruence of two pairs of corresponding sides and the corresponding included angles of two triangles proves triangles congruence. We called it SAS congruency postulate. And in this lesson, we're going to learn two more. We're going to learn about angle side angle postulate and the angle angle side theorem. So I'm going to give you an example of what these look like. Right? We'll start off with like angle side angle. Angle side angle would be something like if I had an angle, then an included side, and then an angle. Okay? Something maybe like that. Okay, do I have your attention? Are you still taking another quiz? No? Okay, I've got you up here. Okay, great. All right, so the orientation of the second one doesn't matter. It doesn't have to be the exact same orientation of the first. For instance, it could be here, here, and here. All it matters is that I've got an angle corresponding to an angle. I've got a side, which is included, and then another angle. So do we understand this? Like I could take this, I don't know if this will let me do it or not. Yeah, it will. Now granted, the little tick marks aren't going to follow it, but just so that you understand, right, I could flip that around, right? Now granted, because it's not an equilateral triangle, it's going to look a little goofy whenever I do that, but the orientation doesn't matter. Okay, do we follow? Okay, so this would be an example of angle side angle. Over here, let's do an example of angle angle side. So I can do angle angle side, and because I don't want to mess you up too much, so we would do angle angle side. Okay, but it has to go in that order in a sense. Now, could you read this off as side angle angle? Yes, but we're going to write it up as angle angle side. Okay? So I don't want you to get too caught up in where these places are specifically, but I want you to understand where they are in relation to each other. Okay? So as we read them, I read angle, side, angle. Okay? Do we understand this? Maybe, hopefully a little bit better than we started off with yesterday, right? A lot of people really struggled with, you know, included sides and included angles. So I kind of want to go over included sides and included angles here for just a second. And I want to catch Jordan up to speed here, right? Let's see, if I label this triangle ABC, and I've got this angle and this angle, can you tell me where the included side is on that triangle?
The included side.
The included side. Okay, so you're saying right here then. Is that correct?
Wait, for ASA or whatever?
For angle side angle. Yes.
We just did.
Yes.
All right.
You want it over here?
Oh, I can't go back to
Okay, so we got triangle DEF. Okay, I just want to know which is the included side. Let me kind of break it down for you. When we say included, we mean in between. No, if it's the included side, it's going to be the side that exists between two angles. Okay, so if I put my angle here, another angle there, can you tell me where the side is that is included? The right side, right there, correct? Now, we would call that more specifically line EF. Okay? All right, so if we come over here and I ask you, I've got this side and this side, let's call this A, B, C. Can you tell me which angle is the included angle? Angle A. Okay, good. All right, just so that we're caught up to speed and we're a little refreshed on that, okay? All right, let's keep moving ahead. Okay, so this is basically just stating more clearly what we've already covered with angle, side, angle. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then those triangles are congruent. Same basic premise here on angle, angle, side. If two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of another triangle, then the triangles are congruent. Okay? Hopefully we'll see some more examples here in a little bit, which should be coming now. Okay, so these are some of the types of questions that we might see. Question number 1. Let's make sure that we're all looking at what I could pull up Go Guardian, but I'd rather just walk around and make sure we're where we should be. Okay, what is the measure of x, y? Now, first off, are these two triangles congruent? Yes. Okay. What congruency postulate am I using there, Chandler? You don't know. Okay. Well, what you look at the tick marks, right? Tick marks are all right here, correct? Okay. Am I starting with a side or an angle? Okay. So here we've got an angle. What happens next in order? Side, and then what happens next? Angle. Right? Over here. Angle, side, angle. Right? So we have an angle, side, angle congruency postulate. Correct? Okay. You're just reading them. You see what I'm saying? Okay. Okay. All right. So because these two triangles are congruent, that means their corresponding parts are congruent. All right, so we want to know what is the length of xy. We want to know what is that length right there. Okay, well, I'm going to look at xy, and I'm going to look for common traits. So looking at like angle y here, right? Well, what does angle y correspond to on triangle LMN? Angle y corresponds to angle M. So what does side xy correspond to on triangle LMN? ML. Okay? So if these two triangles are congruent and ML is 12, then what is xy going to be? It's going to be 12. Okay? Do we understand that? Okay? Now, what I could do there is I could have written up a triangle congruency statement where I said triangle LMN is congruent to triangle, let's see, if it was LMN, then it would be X, Y, Z. Okay? And if I want to know what XY is, then I'm going to look for LM. And LM is 12, so XY is 12. Okay, so I can look at it straight from my congruency statement if that helps. Does that make sense? Okay. Here, let's just... Okay. Let's look at another one here. Determine if you can use angle, side, angle to prove that triangle CBA is congruent to triangle CED. Now we want to use angle, side, angle. Can I use angle side angle? Well, do we have an angle that's congruent? A, right? But what about angle A and angle D? Those are the same, right? Because right angles are 90 degrees. 90 degrees equals 90 degrees. So we've got an angle. Do we have a side? Okay, side what? No, not side AD. AC to what? DC. Okay, so we've got an angle and a side, which means I can't pick angle B and angle E, can I? Even if I knew they were congruent, it wouldn't be angle side angle. What angle does it have to be? If it's going to be angle side angle, what angle does it have to be? No, we've already used A and D. What angle does it have to be? We have to go in order. C. But we can't say angle C because C is a vertex of like 4 angles, right? 1, 2, 3, and 4, right? So saying angle C means absolutely nothing at this point. Okay, so we have to be more specific. Okay, Michael, what do you think? No, we don't have an, and even if you did, right? Let's say that we knew that. That would be angle side. Would we be able to use angle side angle? No. The only way I'd be able to do that is if somehow I found out that AB was congruent to ED, but I don't have enough information for that. Katie? Okay, you guys were on the right track. Maybe I said some things that shook you off of it. You were right when you said angle C, but we have to be more specific. Okay, I can't say angle C. What I'm looking for is angle ACB, right? ACB, because I can't just say angle C in this case. I could say just angle A, and I can say just angle B, but I can't say just angle C. Do you understand why? Do you understand how to label an angle that is a vertex of multiple angles in order to get specifically what we're talking about? All right, we understand why I used ACB. You could also say BCA for that matter, but C's got to be in the middle. Okay, what is angle ACB congruent to? DCE. Does anybody know why they are congruent? How do I know that those are congruent? Because there has to be a reason why. I don't have enough information to prove that B is congruent to E, but I do have enough information to prove that angle ACB is congruent to angle DCE. And it comes down to one of those things that I told you when I taught you that you will have to be able to identify it. You'll have to know it because we'll use it all the time. They are vertical angles. Okay, so vertical angles are congruent. So now, because I know that they're congruent, because they were vertical angles, do I have enough information to say angle side angle? Yes, I have angle side angle. All right, so the rest of this is just looking at it. AC is congruent to DC. That's given, and that should say that all the way through. Angle CAB is congruent to angle CDE because both are right angles. And then the next line says no other congruence relationships can be determined. So that's not applied. Well, that's not true. So we keep going down. Okay. Now I'm going to go ahead and erase this so we can look at possible answers and see which one is right. Okay, because we should be finding vertical angles in here somewhere. Okay, we saw AC congruent to DC, CAB, CDE, both right angles. We're not using adjacent angles theorem. Let's see. Look here. Vertical angles theorem. Angle ACB is congruent to, yeah, that would give me C and C. Therefore, we're congruent by ASA. Now, this last one, you'll notice, has all that same information, but there has one wrong thing. Does anybody know what the one wrong thing in option D is? It says side angle side, which is not what we were trying to prove. and we couldn't have proven it side angle side anyway. Okay, so are we seeing how some, I mean, this is a proof. Do we see how to use some of these things? You have to get better at this than what we are showing today. Okay. Okay. All right, we want to look at this. Let's see, what time are you guys out of here? I want to make sure. 51. We probably have time for maybe this question. Okay. Okay. So I've got angle, angle, side. I've got angle, angle, side. And I don't, if I remember right, I really don't like this question because I have enough information at this point to prove that these two triangles are congruent, right? Okay? Because we have an angle, angle, side congruency postulate. And that's what they're wanting to use. Complete the following proof of the angle, angle, side congruency postulate. They tell me angle B is congruent to angle F. They tell me angle A is congruent to angle D. They tell me that BC is congruent to GC. They say we've got that. We've got our given there. Angle C is congruent to angle G. This is what we call the third angle postulate. And that's typically how we write it. If I know two angles of a triangle are congruent to two other angles of another triangle, then their third angle has to be congruent. And I believe that we've talked about that before. Okay? So you'll see third angle theorem show up here on two of these, so that gets it between C and B. Okay? Next part is given. And so they actually wind up, I believe, with not, let's see. Yeah, and so they rewrite it as ASA. Okay. I don't know why they want it. I think it's because angle, angle, side is a theorem, whereas angle, side, angle is a postulate. And do we remember the difference between postulates and theorems? Postulates are a fact. Theorems have to be proven. Right? So they've given me the angle, angle, side congruency theorem, and we want to prove it, which means we want to end with a proof, which is why we end down here with angle, side, angle. Okay. Okay. Congruency postulate. Okay, do we understand that? We don't want to end with a theorem. We want to end with a postulate. Okay. Hopefully that's enough information to at least get you started into some of this. There's some others in here that they're mainly proofs, or some regular question types down in here. I highly suggest going back through and looking at the rest of the questions that we didn't cover, because questions that we didn't cover are sometimes the questions that show up on tests. Okay, and you have the answer key at the bottom of this. And you can always email me if you do one of these questions and don't quite understand it.